Hi guys, my name is Myrna. Welcome back to physics. Today we're going to be doing our first unit, which is kinematics, and we're going to be doing 1.1, our first lesson in that unit, which is conversions. So let's get started. So first we're going to be talking about a few terms that we're going to be using in almost every single unit this year, and we're going to be using these terms in the future more in depth, and their measurements that are needed to describe objects in motion. So these are kinetic energy, potential energy, velocity, distance, force, speed, time, mass, height, and momentum. I'm just introducing them today, but each one is specific to each unit, and we're going to be going more in depth with their definitions and how they're used in word problems and in everyday. So as I said in the intro, today we're going to be doing conversions. So MKS is the system of units based on measuring length in meters, mass in kilograms, and time in seconds. This is known as the International System of Units, SI. So in every problem that we're going to be doing in physics, we're going to need to convert every single unit into meters, kilograms, and seconds. So the M in MKS stands for meter, which is our unit for length. The K in MKS stands for kilogram, which is our unit of mass. The S in MKS stands for second, which is our unit for time. So last video, I told you guys to download the New York State reference table for physics. And this is on the first page of that. We're going to be needing this chart for conversions. So basically what we're going to do is we're going to need to convert everything back to meters. So in order to do that, we're going to take the form that it's already in and multiply it by its notation. So for example, if it were millimeters, we would go all the way down to milli, and we would see that 10 to the negative 3 is its notation. So we would take the measurement that it's given and move the decimal place either to the right or to the left. If it's a negative notation, we're moving it to the left, and if it's a positive notation, we're moving it to the right. I'll show you guys in the next few examples. Alright, so our first question says, how many meters are in 60 millimeters? So we'd go back to our reference table. We'd write this notation right here on the top. Negative 3 means we're moving to the left since it's negative. And 3 is how many times we're moving the decimal place. So we're seeing 60 millimeters. The decimal place is right here. In order to get it back to meters, we're going to be moving it 3 times to the left because it's negative. 1, 2, 3. This is our new decimal place, and the 0 is right here. So it would be 0.06 meters. Alright, here's our next problem. So how many meters are in 5.2 kilometers? So let's look at the table. Since we're dealing with kilometers, we'd go to kilo and then 10 to the third. So our notation is 10 to the third. Since the 3 is positive, we'll be moving 3 spaces to the right. So 5.2 and then 3 spaces to the right. So it would be 5,200 meters. Alright, here's another one. How many meters are 920 centimeters? 10 to the negative 2. So 920, since it's negative, we're going to be moving to the left 2 times. Here's the decimal. 1, 2. 9.2 meters. Alright, now let's start doing questions that are dealing with time. So number 1, how many minutes are 9 hours? Now this conversion isn't on the reference table, but by New York State region standards, it should be common knowledge. So we know that 1 hour has 60 minutes. So we could set up a ratio. So 1 hour over 60 minutes will equal 9 hours over x. So 9 times 60 equals x. So that should be 540 minutes in 9 hours. Alright, here's another question that's dealing with time. How many seconds are 9 hours? So this could get a little bit more complicated because there is a middle step. So we know that there are 60 60 seconds in 1 minute and 60 minutes in 1 hour. So first we're going to convert our hours to minutes. So we're going to do 9 times 60 because we know 60 minutes are in 1 hour. So 60 minutes times 9 is 540 minutes. So we got that from the last problem. Now to take it a step further and convert that into seconds, we're going to multiply the 540 by 60 again because in each minute there are 60 seconds. So we're going to do 540 times 60 and that will equal 32,400 seconds. All right, now this is probably the most complicated time problem we're going to be dealing with today. So this is because there are now 2 steps in the middle. So it wants to know how many seconds are in 2 days. Well, we know that there are 60 seconds in 1 minute, 60 minutes in 1 hour, and 24 hours in 1 day. So first, let's convert the 2 days into hours. So we know that in 1 day there are 24 hours. So 24 hours times 2 days will give us our 48 hours. Then we'll convert those 48 hours into minutes. Well, we know that each hour has 60 minutes. So we're going to do our 48 hours times 60 minutes. That should give us 2,880 minutes. Now we're going to have to multiply that by another 60 because that we know in each minute there is 60 seconds. So 2,880 minutes times 60 seconds. That will give us 172,800 seconds are in 2 days. All right, we've reached the end of our video. I know today was super simple, but next week I'm super excited because we're going to be discussing types of graphs, definitions of some key terms in this first kinematics unit, and we're going to be using our first formula straight from the reference table. So I really suggest you download it, if you haven't before. Thank you guys so much for watching. I'll see you in the next video.